Okay, I'm ready. How you doing? Thanks for having me here today. Very good. Thank you, Kevin. So today's agenda, as Kevin had mentioned, we're going to be focusing on point clouds. We'll look at laser scanning point clouds for providing additional data that can be brought into Navisworks scenarios. Some of these are using laser scanning for construction and maintenance, especially when it comes to areas around safety. Also using this as a way to create more current as-built information. So typically, as-built information, if it's built from a model, does not take into account things such as deflection, settling, or even bent structures. But having a snapshot allows us to take into account some of that information, and then when we go out and either expand upon this model or remodel or any kind of renovation, we have a more accurate information that we can work with. Also be able to look at how we can take laser scan data, this point cloud information, and link out to both asset and additional facility information. So using some of the hyperlink and data tool features inside of Navisworks, we can link out to external databases, and now this becomes more of a comprehensive FM solution. And finally, we'll look at ways that, in this case, we can use a combination of Navisworks as well as point clouds to monitor excavations, and we can use it for equipment planning as well as site access and even layout management. At this point, I want to change over to exactly what is a point cloud. And you hear me using the term laser scanning as well as point clouds. So laser scanning is the process of taking a piece of equipment, like we see up on the upper left there, and it goes out and physically scans. In this case, this is the Mackenzie Maze infrastructure in California. It collapsed after a fuel truck caught on fire underneath that. It takes a series of points and spatially positions these that can then be grouped into a larger group of these, and from a distance it looks like almost like a picture. So it's basically taking a bunch of pixels that are spatially represented and then putting them into a cloud of sorts. And so the output of a laser scan is what is called a point cloud. So when we hear the combination of either point clouds or laser scans, it's really one and the same, but the point cloud is the output of an actual scan. So what we're looking at here are actually some different point clouds. These are scans that we're taking of a facility out in the Boston, Massachusetts area, and you'll notice that when we get them to a very high resolution, they almost resemble a photograph. So this is an interior shot where they use the scan. This is very useful for working with as-built information. If you're going to be coming in and maybe doing a fit out of an existing facility, now you have an accurate representation of all the material, the metals, the structural systems, as well as fire sprinklers, and some additional elements that you might find in a structure like this. We can also utilize this for exterior. In this particular case, this was a building facade that was used more for historic preservation. They were able to set up a laser scanner and take an accurate point cloud, which then can go back and then be useful for additional work maybe on the inside, or if they're going to need to shore up parts of the facade during the renovation process. So some of the benefits of laser scanning are, number one, it's extremely accurate. We're talking about thousandths of an inch here. We can create very realistic and accurate 3D models. Having this kind of information, now when we import that into something like Navisworks, we can leverage that accuracy, combine that with other models, and now we have a truly comprehensive composite model, taking into account existing information as well as potentially new models that we're going to be working with. We also have a large amount of data and coverage area. So the laser captures everything in its sight. So we can basically go out and take a series of snapshots, stitch them together, and now we have a very accurate site information. Rather than trying to go out and survey this information, we can take this large amount of information and capture it rather quickly. And that's the third point, which is the rapid data capture. We can go out and take a series of these scans and capture incredible amounts of information, but in a short time frame. Currently, a lot of the laser scanning is currently used for forensics investigations where there's like accidents and they need to be able to go out and take a quick snapshot and be able to go back and reference the information, but time is of the essence, so they can't keep the freeway shut down, or if there's a specific let's say the building collapse or something like that, we want to be able to get in and start taking that apart and working in it much quicker. So we can go out and take a series of snapshots which then we can reference later on and have that accuracy. And finally, the last thing, remote data capture. It allows us to measure such dangerous conditions. So for example, high voltage lines. In looking at it from more of a civil standpoint, when we're putting together, say, a bridge and we need to be able to bring in fairly large components, we can use Navisworks to map out not only the direction these components would be brought, but we can use laser scan data that would show us the route, so we can determine if there's going to be clearance between maybe some high voltage lines in the area, rather than trying to rely on maybe outdated maps or pictures, or even try to bring someone out there to accurately measure that. We can bring out a laser scan, take a very accurate snapshot, incorporate that into our Navisworks model, and then we can then utilize that with some of the planning process. So on screen, just give this a second to catch up. I'm inside of Navisworks now, and this is a small snapshot of a boiler room. And you'll notice now that as I move around this behaves almost like a 3D photograph. If I zoom in close enough, you'll notice that it's actually nothing more than a series of points, and I'm not sure how this is going to appear on the other end, but really it's nothing more than millions and millions of points embedded geospatially positioned properly. And in doing so, inside of Navisworks, now I have the ability to interact with existing information. So this behaves just like a 3D model, but the nice thing is that it's existing information that we can go and capture from, in this case, the basement of a boiler. So within Navisworks, I can now utilize some of the basic navigation tools. You saw me moving around this. I can also utilize something such as the avatar, and now use this as a means to navigate through this. So from a safety standpoint, we can start planning out some of our additional information ahead of time, start looking for safety issues within this, or we can even look at this from like abatement purposes. We're looking at this from this snapshot, we'll call it, from the basement of a boiler room. And now with this information, we can start planning out possible work scenarios. We can look at bringing additional equipment in here. We can start to notice that there's a hole in the floor in front of this avatar. Really start planning out and really getting a good understanding of what's going to be involved to work within this particular space. I'm going to jump over to another model, and this one I want to show you, this is actually a series of 4 different scans. So as I mentioned earlier, when we run out and take a laser scan, we're really just taking a series of different snapshots. But the nice thing about these is that we can use GPS and have them reference each other, so we can have them stitched together and create a very large composite model, which then we can use for other purposes. So in this case, this was the first snapshot that we took, and you notice we can start to see the basis of some of the different components in here. If I introduce the additional scans one at a time, you'll see how they start to add additional information to the overall scan. And finally, if I add all the scans, now we have a much more detailed model. So in this particular view, we took four different scans from 4 different positions, stitched them all together, and now we have one composite model which we can utilize the navigation features. We can still interact with this, as I mentioned, using the avatar. Or in this case, we can now start to bring in additional elements. So one of the features from a construction and maintenance perspective is we're going to be working on an existing building, but we're going to be adding in some additional components. Utilizing this point cloud, we can now combine this with our digital models, and we can start looking at things such as clash detection. So in this case, I'm going to bring in these other 2 components, and in doing so, now when I back out, we can see on screen we have the newer components which are going to be fit into this existing area. But using the clash detection feature inside of Navisworks, I can now go ahead and determine if this particular design will fit within the parameters of this existing structure. So let me go ahead and move in here. And this is really where it becomes useful. Where you're working with existing and you have new, or maybe there's some demolition. You want to make sure that you want to be able to take into account the space that's going to provide. Once I have this information all lined up and sequenced inside of this building, I can now leverage the clash detection. So if I open up the clash detection in Navisworks, and when we run clash detection, typically we're looking at surfaces. We're saying I want to calculate the surface of our structural model to make sure it's not going to interfere with the structural, or maybe our MEP. In this particular case, because our point cloud is really nothing much more than points, we can't treat it as a surface. So we need to treat this as millions and millions of points. And Navisworks gives us the ability to both manage not only surfaces and lines, but also points. So for this iteration, I want to make sure that these new components that I've introduced in here, these you can see the structural members as well as some of the piping, is not going to interfere with any of our existing conditions here. So on the left side here, I'm going to go ahead and select Scan 1. And I'm just going to take one of these initial scans at first. Now remember, there's 4 different scans that we can choose from. But if I use just the initial one, and then for the right side, I'm going to go ahead and select, this is our new components, our structural components, piping. And when I run the clash test, at the bottom here, it gives me a couple options. It gives me the surface, line, and point. On the point cloud, I want to recognize that as millions and millions of points on here. So I'm going to make sure that I have that selected. But I'm going to be clashing that against surfaces. So I'm going to have the surface tool selected for the right side of the clash. When I run this clash, as I mentioned, typically Navisworks is looking at surfaces. There's a physical interference between 2 pieces of geometry. Because we're working with points, we can't use what's called the hard clash. Rather, we need to create a clearance clash. And what this is establishing is that within the distance between these different points, if one of the surfaces comes in contact with that, that's what's going to trigger our clash. So when we run this, we're actually going to treat it as a clearance clash, but we're going to set our tolerance for a very small amount, and that's going to be representative of the distance between these different points. And in doing so, in this case, you can see it found three clashes. If I go over to the Results tab in Navisworks, now it's going to show me not only these particular clashes, it's going to highlight them on screen, but it's going to now take me into that particular view. Now, because we have a lot of different colors on screen, what I will typically do is I will go ahead and override these colors on here to a nondescript color, so that we can now, when we highlight those elements, it's much easier to see the changes. And the same goes for, I'll go ahead and override the colors on these new components as well. And what I'm doing is I'm just right-clicking on the model and then go down to override color, and now I can change the color to a to a more uniform or less obtrusive color. And now on screen you can see the clash elements will stand out. They're showing up in bright red. and I can see between these two elements, I'm seeing some clashes on here, and it's a little more difficult to see, but now I can see that this particular vertical column is interfering with some of the existing conditions there. So just using the clash test, we can quickly identify areas where there could be some conflict between new and existing. And once again, we can use this on all the different clashes on here. Move around here and identify the particular clash. So because the point cloud is typically a little larger, we're seeing a lot more area involved, but one of the things that you can do there's some existing software out there that allows us to take these point clouds and break them down to smaller elements. So now in effect they become more representative of the actual element, and there's also additional software out there that starts to take these point clouds and create a series of surfaces so that they almost behave like a 3D object. So right now we can see here's the potential conflict right here. We have this horizontal pipe, and it's impacting one of the existing pipes that are already in place there. So leveraging this information, we could go back and make necessary design changes, resubmit this model, and go through the clash detective again. So this is an example of bringing existing information in the form of a point cloud and then utilizing that against some new information inside of Navisworks. We can also do a couple of other things in here as well. Up to this point, we've looked at just the general clash information, but I talked about bringing in new information as well as models. We can also go back and we change sides here. In addition to, we'll keep it on this so this will work. In addition to looking at just clash information, we can also use this existing model to track more of a 3D asset tool as well as facilities management. So one of the things that Navisworks does very effectively is manage external data, and we've seen this in case of bringing in different model types, but we can also link out to external databases. One of these, the more common way of doing this is when we link out to like a scheduling application like Primavera or Microsoft Project. We can link in those start and end dates, and then using one of the timeliner features in Navisworks, we can now go back and sequence these activities. But one of the other options we have is to be able to link out to like an Oracle type database or Microsoft SQL Server. Leveraging this information, now we can use this model more from an asset management and like I said, even a facilities tool. So what I'm going to go ahead and do is I'm going to go ahead and I want to close out of our clash management, and I'm going to go ahead and override the colors to get us back to the standard colors that we were working with. And now in this model, what I want to go ahead and do is I want to create a series of hyperlinks that link out to outside data. And we can do a couple of different options on here. First thing I want to do is I'm going to hide the existing, go ahead and hide the new proposed structures that are on here. And then now they'll give us a little more ability to move around the model a little easier. So one of the things that I noticed early on in the scan was that there was a fire extinguisher in here. And from a management and planning standpoint, sometimes it's nice to be able to get additional information about this. So inside of Navisworks, we can create a series of hyperlinks to any specific element. And one of the ways we can do this is to simply select the element. In this case, it's this particular model. And then if I right click on here, you'll notice I have an area here called hyperlinks where I can add additional hyperlinks. And now this is nice because we can point out not only to a specific URL or file, but it can also point out to an area, a database on our machine. Once we've established this hyperlink, we can use the hyperlinks tool to have these show up. And now you'll notice I have a hyperlink on this fire extinguisher, and simply selecting that will now open up to take us out to Fire Extinguisher 101. So it gives us the ability to link out to external information by embedding different hyperlinks or tags inside of the Navisworks model. Back inside of Navisworks, though, we can also utilize this external linking and link out to a more robust database. So one of the things, if I open the Properties tab and simply clicking on one of these elements in here, it gives me some general information about the model. Now, in this case about point cloud, there's not a lot of intelligent information that's embedded in that. It gives us some basic information, what type of information such as where the source file was, what kind of application created it, and so forth. We can take this information that's in here, and now if we have like an outside database, so for example, I have an Access database that has some general information about boilers and some of the pumps that would be incorporated in there. Inside of Navisworks, I can now create some specific handles, like what I've taken is some of the existing information, but I can create my own values in here. So I could put in a marker or a tag, which then can be referenced by that database. So in doing so, if I go to File Options and create, selecting the Data Tools, I can now embed maintenance information into this existing as-built. So I'm going to select OK. And now what I've done is I've created a SQL script, this is part of this data tool, that says link out to that Access database. And when I select this, now it gives me a tab up here for maintenance details. And what I can do now under the maintenance details, now it gives me some general information about what's incorporated in this scan. And now I can see that there's a boiler in here, the last maintenance date, the next maintenance on this, where the manual is located, and who the particular contractor was on that. I could now embed additional information, but what we're seeing here is being representative of this database. So as the database gets updated from time to time, all the information that's linked into your Navisworks model will update as well. So it becomes a very useful tool to plan and be able to manage the facility. Now where this becomes even more useful, if I minimize this, leveraging the Find Item tool, I can now search through the model and say find me all instances of a boiler that needs to be maintained within let's say 6 months. So bear in mind, when I was looking at the property information, that information from those database carried over. Now in the Find Items, I can search out for maintenance details, and I can say I'm looking for the next maintenance, and then for condition it gives me a couple of options here. I can look for a specific date, or I can say greater than or less than, and then now it's showing me the different values that are on here. I can simply select one of these, and if I had more additional values on here, then I could then have a greater opportunity to search that. But now searching through that, it's going to highlight that particular file. So if I have smaller scan and smaller amounts of data, I can now use this as a tool to quickly search through a larger facility and quickly isolate the different elements that I need in terms of different maintenance, or in terms of next maintenance, I could even look at the time it was last maintained, or even specific part names. Now this is a fairly large scan file, so it's encompassing several different types of elements in there. But one of the things I was commenting on is how we can take this scan and now break it down into smaller elements, or even take it and have it create surfaces and treat it more as proxy elements, and that can be brought into Navisworks. So we've looked at a couple of different ways of taking this point cloud, which can really be thought of nothing more than a series of points, bringing this in, using this to look for the areas where there could be potential clashes. But now we can also leverage this information to look at it from facilities tools, where we can embed information in there and then have that linked out to an external database that's going to get updated from time to time, and then simply coming in and then using this point cloud as a visual indicator really allow us to understand where those particular items are located. And when we get into a larger structure, you would have much more ability to look into that deeper. One of the other things too we can look at, and this goes back into the going back to our initial talking about managing the construction process and safety. If I switch gears here, I'm going to jump over to one of the other models that it's on here. And this particular case, let me give it a second to catch up. This is a planned excavation, and what Navisworks allows us to do is now we can link in both the scanned surfaces but also the building model. In this case, we've determined that we're going to have an excavation approximately 35 feet deep. We can show the piles and everything, but what I can do now is I can import the existing surface, and we can start looking at what-if scenarios. With this information, now I can start planning on what this is going to look like, how much equipment is going to be required to excavate this, and it becomes more of a site logistics planning tool. So if I go back to the selection tree, one of the things I'm able to do is I can now select the surface, And then using the override transform, I can now move this up and down and start to figure out approximately, the kind of equipment I'm going to need in here. But more importantly, if I have a couple of planned metrics that for example, I say I need to make sure that I have enough soil excavated out by, the end of next week, in my building model, I can create a series of horizontal planes that represent the level that we need to get down to. So if I actually draw a section through this model, and you can see on screen now I have a series of horizontal planes. These represent the level that I want to be excavated down to by maybe next week, the week after, and then let's say the following week. And these become critical because now I can overlay the scanned surface and then determine if the contractor has achieved that goal. In this case, we can see that there's still a significant amount of dirt above that planned surface. So with this information, I could now determine that, maybe on the pay application at the end of the month, I'm not going to award the full amount because there's a significant amount of excavation still left. We had a milestone that said you needed to be down to this particular level, but we're still, a couple feet above that. This also becomes useful too when I start bringing in additional, elements. So for now, I can bring in an excavator and start determining, is this going to be, bringing in third-party elements or outside elements. Now we can incorporate these into the model, have them move around, determine, is this going to be a large enough excavator? Maybe we need to bring in 2 excavators or bring in a larger one. And where this goes back to is if I jump up a slide here, a lot of times you've probably seen pictures like this in the past and trying to determine, is this the best way of managing an excavation site? In several of these pictures you can see, there's the tight working conditions of the one on the left, and then obviously there's some different challenges with all of these. A lot of times, it's trying to plan this out can be more of a difficult challenge, but going back to Navisworks, we can now bring in these different 3D elements, incorporate them into the site. We can overlay the existing conditions is with the planned, and now we can start to go around and determine if one thing, this equipment is going to be appropriate for the challenge, or we can start looking at this to see if they've met the goal from an owner project manager standpoint. The other thing we can do too with these laser scans, and this becomes really critical, is when we look at the end of a project, we typically have a series of as-built drawings, or sometimes it's an as-built model. But what that doesn't take into account was the process that they went to get from point A to point B. What we're looking at here on screens this is an excavation, and they took a series of laser scan snapshots throughout the project. So at the end of the project, not only do we have the as-built, but we have an archive of the whole construction process. A lot of contractors will use webcams or go out and take job photographs to document that process of how a construction project is put together. However, we can use laser scan data to really accomplish the same thing, but importantly, we can actually work with that, meaning it's not just a 2D static image. We can go back in, leverage that data, and now go back in and determine maybe there were some issues that we want to try to learn from, or create some lessons learned so the next project we don't repeat those. Or if there was maybe an accident or any kind of a litigation, we can go back and determine, was there any room for error, or could these errors have been avoided? So what we're seeing here are just some snapshots that show the surface of this particular excavation, and then the associated date. So basically once a month, or it looks like about twice a month or so, they were taking these different snapshots, and then that gives us the ability to go back and reference these. This is another snapshot of the same process too, and this is kind of what I was talking about on the bottom. You can see at the top here we have two open excavations. One on the left is an actual picture, and then the right is with the picture, but it has the scanned information overlaid. Utilizing the section tool in Navisworks, we can quickly determine, have they achieved their goal? Where they managed to dig down deep enough? And then having some milestone place marks in place allows us to verify the depth of that. But we can also simply use the measuring tools inside of Navisworks and determine, the depth of the excavation, as well as, if it was, if it was incorporated within the area as they had requested. So I'm going to go back over to our data set and talk about just a couple of different methods here. With Navisworks, we can bring in over 40 different file formats, and this becomes very useful for working with applications like AutoCAD, Revit, some of the different file formats that are out there. But in terms of actual laser scan data, Navisworks can actually bring in quite a few different formats. And you'll see here on screen, if I go up to the open area, we only have, you can see all the different file formats it brings in. So it brings in your standard ASC and text file laser scan data, but we can also bring in the Leica format, which is more of one of the common ones, and you can see we even have some of the additional formats in here, as well as the ZNF, which is this one is. Armed with this information, we can now go back and change the appearance of this. And if let me switch over to my other model here real quick, this will be a little easier way of showing this. This particular model right now is brought in at a fairly small sampling rate. However, if I go up to my global options and under the file readers, just give this a second to open up here, I can now go ahead and change the sample rate. So even though the point, the laser scan created this point cloud, it was very, very detailed. If I want to maybe have this open a little quicker, I can change the sample rate, but I can also change the point intensity of this. So these are some of the features that are built into Navisworks. So right now we're looking at a color mapped intensity. However, I could say I want to see nothing along the lines of that. And then now select OK. And then if I refresh this model, and this will take just a few seconds here, you'll see how we can change the appearance of this. So once again, Navisworks gives us the ability to not only work with the model, but now we can change some of the resolution, some of the other settings on there. So as our model gets larger and larger, we may want to keep this point cloud as small as possible for the time being, just so that we're able to interact with the file. And then maybe at the end of the project we want to do a fly-through animation. We can go back and change the resolution to almost a 1:1 or 1:2, and at that point now we'll have a very detailed model. So just making these few changes, you'll see here in just a minute how this affects the overall appearance. So right now this is a very lightweight model. It's easy to maneuver around, but you can see how much of the definition I've currently lost. So being able to change the resolution as well as some of the color features towards the end, now we can have this as a detailed model, incorporate additional elements inside of that, and then if we want to look at it from a fly-through or create a series of animations, we could then increase the realism of that. But from a general standpoint of just general navigation, we can minimize this, and now it's much easier to maneuver around to bring in additional elements, and it keeps our file size small while we're going through a possible design review process. So let me change to a couple things here, and then we'll have some time for question and answer. But wanted to, let me find this once more here. It's not the one I want. Okay. So we've talked about some of the different ways we can use laser scan data. They can be useful for bringing in additional information into Navisworks in the standpoint that allows us to work with existing conditions, but also incorporate new models on top of that. We also looked at ability to take these two different mediums and clash them and allow us to iron out any conditions between installing the new equipment, or maybe it's excavation. But utilizing the old and new gives us now a true as-built as well as composite model. We can also use this to link out to external databases. So in addition to bringing in multiple file formats, we can now link out to access databases and embed that information into the model. This now becomes useful from almost a facilities tool, where we can take a snapshot of a mechanical room and then have a very accurate system in place that we can now try to incorporate new components. But now we can also link over to and then search within Navisworks using its data tools and find items features. We can link over to external information. And finally, we looked at a case study here where we can use point cloud data to encompass an excavation. Being able to reference that with the as planned now allows us to look for errors or any slippage in our project schedule. The next step I could do with this would be to link over to a project schedule that would say, here are the milestones that we expect to have this done, and we could animate some of these some of this excavation, and now we can start using this as a tool for the project manager to start to establish where are we slipping in our schedule, or where are we running into safety concerns, and maybe even from site access as well as working with equipment, starting to determine, is this the right amount of equipment for this job? Do I need to bring in two of these excavators, or maybe a larger one, and start figuring out ways that we can maximize the efficiency of this. So this is a fairly simple procedure with importing point clouds. As I mentioned, we can bring in multiple file formats, but we can also bring in several different types of point clouds. At this time, I'm going to go back and I want to talk a little bit about what we covered. We talked about the scanning for construction and maintenance, the as-built information where we can look at deflection, settling, and bent structures, and then leveraging that information so that our new structures will match up. We can also link over to asset facility and then monitoring excavations. So the summary for what we've talked about, point clouds are really inaccurate, and you can think of them as a 3D picture. It's millions and millions of points that have been captured and are geospatially accurate. And then looking at this from a distance, it takes on more of a mesh-like appearance. We can then leverage this as a means to really understand more of the graphical appearances of these elements as built information. And then, as I said, use for accurate as-builts. Being able to go out and take a snapshot that not only is a static 2D image, but can be useful for interacting, looking at clashes between possible new components, linking out to outside databases, becomes a much more valuable document. Having it referenced in multiple locations and then be able to interact with that is really a very important thing to have. And finally, looking at it from the point of a 3D asset and facilities management. Not only can we take these points, but now we can take these series of points that represent a specific object, link out to a database. We can then use the search features inside of Navisworks. We can group them, and then leveraging the outside database that can be updated, we now have a visual model which can be useful from a facility standpoint. At this point, I want to make sure we have room for questions, so I'm going to go ahead and open the lines up. At this time, are there any questions? Okay. Sure. Yep, 1 second. Let me pull that open. The question was, what is the file size for a point cloud for this boiler room? Let me go ahead and minimize a couple of these. The actual file size is approximately, let me see if it gives it on here. It's about 100 megabytes right now. This is just telling me some of the basics on that. I don't have an actual, I could go look at the model size, but it's about 100 megabytes. But what's important to remember is that's the raw data information. When I pull this into Navisworks and I go ahead and make changes, change the resolution, it's going to cache that file into an NWC file, which is going to be significantly smaller. So depending on how the resolution I have set for that, the raw data file itself is fairly large. It's several, can be several hundred megabytes. It could be even significantly larger depending on how much is encompassed, as well as the detail and the size of the scan. Yeah, let me go ahead and let me change gears here real quick. I'll show you what the difference in file sizes, because it is important to notice that they are a large file format, but bringing it to Navisworks, when it creates a surface model, a lot of this will cut down on the file size. So the actual file size, you can see here, the ZFC file was 136, about 136,000 kilobytes. The NWC file for that was at 22,000, so almost 6 times smaller. So it is significantly smaller. But the nice thing about this is if with the raw data file, you can always go back and then change that resolution in Navisworks if you need more detail, if you need to have more of the colors. Now obviously your file sizes will get larger when you do that, but you do have the ability to go back and make those changes and have it referenced. So, a workflow example is to keep it as small as possible during your general navigation, and then if you needed to go back and have a detailed animation or rendering, then you can go back and increase the resolution and then render that out, and you'll have more realistic results with that. Yep. Sure. Yeah, so the question was, can we still bring in the multiple file formats and then use this for clash detection? And the answer is yes. If I go back on this model, if I go ahead and let me unhide the additional elements that are in here. So I have these elements which were done in a CAD-like application. I could still bring in, I could go back and append in any number of different file formats in here. And then when I go into my clash detection mode, typically one of the best ways of managing clashes is to take the elements and create a search or selection set so that we're grouping them down by either discipline, location, material, any number of different events. When I open my clash detection model, now I have the different models. So I could have an AutoCAD file, I could have my scan file, I could have Revit files, I could have IFC files from maybe a third-party application. All these different file formats we can now select, and then we can run a series of different clashes. And inside the Clash Detective, we have ways that we can run a series of different tests simultaneously under the Batch tab. So I could create a initial clash, which could be my laser scan versus my HVAC ductwork, for example. I could also create one for any number of clashes, and then just say update, and I can run all these clash tests simultaneously. Pretty much, if it's a design application, it may not bring in not necessarily the native file format, but typically most of those applications can save out. So for example, we can bring in MicroStation files that both DG some of the surface files. And now maybe it won't bring in the XML data, but most of those applications can save to one of these formats that we're seeing on screen. Where this really doesn't work with very well is things like PDFs and image files. Those typically tend to be static and 2D. Really want to work with a 3D format. So right now, this is go ahead. So yeah, most scanners will have a software that comes with it that allows you to stitch together these different scans. In this particular case, this model was built up from 4 separate scans, and I'll turn these off just so that we can. So scan 0, for example, was the initial scan that was done on here, and it's just a small sliver. You can see it doesn't really encompass a lot, but it gets very detailed in this small area. And you'll notice a lot of these have these little blue dots. So these are the reference planes that were set up when they were scanned. That allows them to specify the height. And then that way when they stitch them together, they have the orientation, they have the GIS information for these. But typically it's the scanning software that's going to be bringing these different elements in, and then we'll be positioning. However, we can still bring in multiple elements, and inside of Navisworks, position them around. I can come in and select one of these elements, and either in the override transform, I can move it around on screen, or we can use some of the other tools to snap them into place. It becomes a little more challenging though, because you may not have a clean edge. It may be hard to set, where does one scan start and one end. But typically your scanning software will encompass that. Correct. Correct. Exactly. hmm Okay, so you have a couple options here. If you have an existing CAD file, that can become the as-built. But let's say you're working with an older structure where there's no accurate drawings available and there's no CAD files. You know, it's a turn of the century building. You could hire someone to come in with a tape measure and draft this out and create this. But a lot of times, what happens is you're assuming that pipes are level, that they're straight. Over time, you know, elements will tend to sag. You might find dents, and especially with deflection on some of these different items. The laser scan is going to give you a true picture of what's happened in there, and this becomes very useful going forward. Where you know you may have, if this was drawn as a CAD file, you may show a pipe being completely horizontal, but in reality, because they didn't place the pipe spacing, the pipe hangers properly, there's it's deflecting an inch or so in the middle. That could potentially cause an issue if you were to be introducing some new equipment, and in the CAD file it looked like it was going to be a clear, you had the clearance, but when you get on site and realize that now I have these components are going to be bumping into each other because the existing equipment in this room is sagged over the course of the years, or because it wasn't installed properly. So you're leveraging your point cloud, the scan data gives you a true as-built as what's in there. And not to say that the CAD file is wrong, but it gives you an extra realism. It gives you that extra bit of accuracy that maybe a CAD file will overlook. So one of the things that's out there is there's a lot of third-party software, and this goes back to some of the laser scanners. They will take this information, and now we're starting to see more intelligence built into these, where instead of just having millions and millions of these points, now they'll start to recognize entities and objects. You can now start to create surfaces out of these different points. So in effect, you're creating a CAD file. You could call it, it have more surfaces. In this particular case, we're looking at strictly just the points, but we're seeing in more and more applications where now we can scan this, take these millions of points, and create surfaces which will now behave more like an object. And it's the same process. We could bring that into Navisworks as well. And now instead of having a point cloud, you would have a CAD file or a surface file, which would be representative of that built condition. Any other questions? Mm-hmm. Yeah, exactly. So Navisworks is not a design tool. It's really more of a tool to help you visualize, analyze, and simulate different conditions. So in this case, when I ran the clash, and let me see if I can find it. It was on one of these pipes. Here it is. It's over here in the corner. This pipe that's coming along here, you can see it's interfering with that. I would go back into the design application and probably take this particular pipe here and move this down, just so that it's clearing this issue, where it's interfering there. We could do some of that in Navisworks, and we can say, let's just hold this pipe here, just to verify that this would work. And basically, I've just dropped it down, a couple inches. I could then rerun the clash test, and now if that clash is gone, then I could go back to the design model and say, let's make this change. I need to move this down. But let's say in doing so, I've treated that clash, but now I've caused another one farther over. So it kind of gives you the ability to do some what-if scenarios. But ultimately, it's not a design tool. You would go back to AutoCAD, MicroStation, Revit, whatever application created these initial shapes, and then re-import that back into Navisworks and then run it through the clash test again. Any other questions? Okay. Well, I am going to turn this back over to Kevin then, and he can talk a little bit about some of the upcoming events and details on those. Thank you. Okay. Thank you.